Hey everybody, it's Mr. Miller, and I know that you're glad that it's my turn here to give you a little bit of a video lesson, considering I'm much funnier, better looking, um, smarter than Mr. Griffin. This will be obviously much better than anything that he's done so far. So now that we've established that, uh, the purpose of today's video is to give you some worked examples on how to use metric relations in right triangles to solve for missing side lengths. Um, and the first thing I think I'd like to do is I'd like you to take a look at these letters on the right-hand side, and I'd like you to take a look at them to see if you can place them in this triangle. So I'm going to pause the video as my thing continuously makes that noise. I'm going to pause the video and let you guys do that, and then when you come back, I'll place them and see if you're on the right track. So, welcome back. Welcome back as my thing continues to do that. Um, what we're going to do, yeah, what you did was place these letters, so I'm going to place them for you. The altitude is always the easiest one to place. Um, and as you're going through this, hopefully you get some consolidation in class that some of these letters can be placed in different places, and it doesn't matter. But in order to write the metric relations down, we have to have these letters in place. Um, and so the relations that you were hopefully came up with in class were that the altitude squared was equal to the product of the two parts of the hypotenuse. Um, you also hopefully discovered that the altitude times the hypotenuse was equal to the product of the two legs of the big triangle. And then the third group, I guess, of metric relations, and it's kind of neat if you can see them as a group because it'll help you remember them all. And that's the projection onto the hypotenuse. So that this leg squared will equal the product of its projection and the hypotenuse. And that the square of this leg will equal the product of its projection and the hypotenuse. Um, and so if you can think of these as sort of one relationship, maybe described in two different ways in this case, that might help you remember it and have a good understanding of what it is, regardless of what letters are placed there. Because it's very common that you're, or not very common, I should say, that you're going to get these letters in such a nice way. You may get different letters, you may get different situations, different orientations of this triangle. So it becomes really important that you see these for what they are as opposed to what the letters are. So the next step in this is that I'd like to use those relationships in order to solve for missing side lengths. And so again, I'm going to give you this problem. I'm going to ask you to pause the video uh, to see if you can solve for that question mark, that missing altitude. And then when you come back, I'm going to show you my solution and see if we match, see if our solutions match. So pause the video, and now you've pressed play, which is cool. Hopefully you got an answer. The idea here is that you're looking for the missing altitude, and if I use the same letters as I used in the first video, that this and this and this are given to me. This is the whole hypotenuse and the two legs of the big triangle. Um, and so the relationship that would allow me to solve for that missing altitude, um, the the quickest, I guess, would be that the altitude times the hypotenuse is equal to the product of the two legs of the big right angle triangle. Um, and then it's a straight substitution problem where you're substituting values for, sorry, h times c, 25, is equal to 7 times 24. And hopefully this becomes fairly intuitive, or this is fairly intuitive to you, that you're just basically going to isolate h um, in this situation. H times 25 we can rewrite as 25h, and then basically divide both sides by 25. Scroll down a bit here. And you get an h that is equal to 6.72, and I believe that's centimeters. So if we wanted to sort of come up with a process for doing these things, we'd identify that we have a right angled triangle with an altitude drawn. We'd identify that we have a missing altitude and that we could use this relationship in right angled triangles in order to solve for a missing altitude. Okay? Hopefully you've got that right. I know that I'm pretty confident that you did. So the next one, same kind of deal. Just gonna give you another example using maybe a different relationship. So again, pause and then come back to me when you found the missing measure. Welcome back. And what we're looking for here, again, using the same letters, although I don't have to, using the same letters as I did in the first slide, this would be A, so one of the legs of the big right angle triangle. You'd be looking for its projection onto the hypotenuse, given the hypotenuse. And hopefully, if you refer to those, you'll see that the square of that projection would be equal to the product of, or sorry, the square of the leg of the right triangle would be equal to the product of its projection onto the hypotenuse and the hypotenuse itself. That sounds really wordy, and hopefully I'm not confusing you with it. But again, it's to try and avoid using only these letters as reference. So I'm going to substitute like I did in the previous question. 8 squared is equal to m times 16. 64 is equal to 16m. Divide both sides by 16 and get 4 is equal to m. And I think now that we've done 2, even the third will become even easier because really you're just recognizing that you have this diagram and you're looking to solve for missing sides using one of those relationships. Okay. Okay. Second to last one. This guy here, pause the video. Try it yourself. Time yourself if you want. See if you can do it quick. And then come back. Good, you're back. And you have an answer. Awesome. Looking for the altitude again. But this time, we're given basically the two projections onto the hypotenuse. And hopefully what you remember from the first slide was that the altitude squared was equal to the product of the two projections. And so from there, again, straight substitution, h squared is equal to 2 times 18. H squared would be equal to 36. And then in order to isolate h, square root both sides. H is equal to 6 centimeters. And I guess that was pretty fast, but I think this is pretty fast. Once you figure out the right relationship to use, it's just about substituting and solving for your unknown. Okay. Last but not least, here it is. Pause, and then come back. Great, welcome back. And this one, maybe you were a little bit stumped at first glance because out of all of the relationships I gave you, this is what you're given and you're looking for the hypotenuse. And sometimes we forget that Pythagorean theorem can be used to solve for missing sides at a right angle triangle. And so we always have to remember our Pythagorean theorem from 9th grade so that we can solve for missing side lengths in right angle triangles. This one, maybe even you saw it as a similar triangle to a 3, 4, 5 triangle. So you might have got there even quicker. But the missing side here, oops, will be 10 centimeters. And there you go. So just a little reminder that Pythagorean theorem still exists and still needs to be used. So hopefully that was not too bad. And hopefully that helps you understand or to see how we use these relationships to find missing sides.